In this video, we're going to continue our discussion of Le Chatelier's principle. Of course, Le Chatelier's principle tells us that if a stress is applied to a reaction mixture at equilibrium, the net reaction occurs in the direction that relieves the stress. Put another way, if a reaction is at equilibrium and we disrupt that equilibrium, the reaction will proceed in a net forward or reverse direction in order to restore equilibrium. So we can disturb or disrupt an equilibrium by changing the concentration of reactants or products. We can change the pressure and the volume if we have gases involved in our reaction, or we can change the temperature. In this video, we want to look at the effects of changing the temperature on equilibrium. So when the temperature of an exothermic or endothermic reaction is changed, the net reaction proceeds either to the left or right in order to establish a new equilibrium concentrations, and a new equilibrium constant. So unlike the other stresses, which the Kc value remained the same, when we change the temp, we get a brand new equilibrium and a brand new equilibrium constant established. So in general, when an equilibrium is disturbed by changing the temperature, Le Chatelier's principle predicts that the equilibrium constant for an exothermic reaction decreases as the temperature increases. The equilibrium constant for an endothermic reaction increases as the temperature increases. So this seems a little tricky, but let's see if we can explain why this occurs in a little different terms. Let's examine a couple of reactions. First, let's look at this reaction. Nitrogen plus hydrogen yields ammonia, and we're given that this reaction has a negative delta H. That means that this reaction is exothermic, or it releases heat. So heat is released during the reaction. Another way to think of that, if heat is being produced or released, heat can be thought of as a product of this reaction. So let's write the reaction a little differently. Let's write the reaction, but let's put heat as a product. Well, if the temperature of the reaction is increased, what's going to happen? Increasing the temperature, essentially we're adding heat to this reaction, so we're increasing one of our products. Well, what does Le Chatelier's principle tell us? If we increase one of our products, the equilibrium will shift away from that increase. So the reaction will shift from right to left in order to establish a new equilibrium. So the equilibrium concentrations of my reactant are going to increase relative to what they were before the temperature increase. The concentration, the new equilibrium concentration of my products is going to decrease, again, relative to the concentration previous to our temperature increase. So Kc, we can write a Kc expression for this. And what did we say? The concentration of my reactants are going to increase, and my product concentrations are going to decrease relative to what they were before my temperature increase. So numerically, what effect is this going to have on Kc? Think about it for just a second. If our numerator value is decreasing and my denominator value is increasing, Kc should get smaller, right? So the resulting new Kc value at our higher temp is going to be smaller than our original Kc at the lower temp. So we can see that for exothermic reactions, increasing the temperature results in a smaller Kc value. Hopefully you can see why that is. Here we have a graph of several different Kc values for this reaction at different temps. As we increase the temperature, the Kc values decreases. And so we get smaller Kcs for this at increased temp because this is an exothermic reaction. Well, what if we have an endothermic reaction? Here we have a reaction where delta H standard is positive, which tells us this is an endothermic reaction. Therefore, heat is absorbed during this reaction. Well, if heat is absorbed, we can think of it as a reactant. So let's rewrite our reaction, but here, because it's endothermic, we're putting heat on our reactant side. Well, if the temperature is increased, what effect is that going to have on the heat? Well, if we increase the temp, essentially we're adding heat, and we're adding heat to the reactant site. Which way do you think the reaction is going to shift? Well, if we're increasing the concentration essentially of heat, we're increasing the amount of heat, the reaction will shift away from that increase. That's what Le Chatelier's principle told us previously. So the reaction will shift from left to right in order to establish a new equilibrium. So what's going to happen to my reactant concentrations? Well, the reactant concentrations are decreasing, and the product concentration is going to increase relative to what they were prior to my temperature increase. So we're going to have a new equilibrium constant. Well, if our equilibrium we said is shifting from left to right, our reactant concentrations are decreasing, the product concentrations are increasing. What effect will that have on Kc? Well, my numerator is getting bigger, the denominator is getting smaller, so mathematically Kc should get larger. So the new Kc value at this higher temp is going to be larger than the original Kc for exothermic reaction. So hopefully you can see that. Now be sure, here we've looked at just temperature increases, but be sure you can use this same logic to explain the change in Kc if we decreased the temperature in an endothermic or exothermic reaction. So take some time and think about those scenarios when we change the temperature.